Hello guys, it's Mrs. Rodriguez. I was just thinking, have I ever told you how amazing you guys are? Well, if I haven't, I just did. So today we're still going to be talking about writing expressions, but we're going to practice them together. So what I want to do is I want to take a look at these problems, and I am going to have you pause the video and try to write these as algebraic expressions. So there's 8 problems here. You're going to pause the video and you're going to test out how good you're able to pick out those keywords and those important phrases to help you to write algebraic expressions. Okay, so go ahead and work on that. Pause the video. And then once you're done all the way through number 8, hit play again, and I will work through them for you so that you can see how you're doing. So this is a good way to do a checkup and see if you're understanding how to set these expressions up, okay? So go ahead and pause. Okay, so hopefully you've just come back and you have worked all of these out and you're feeling confident, and I hope you are feeling confident. Even if you end up making a couple of mistakes, it's okay to feel confident about math if you're thinking that you've got it, okay? Remember, mistakes don't mean that you're not capable of doing it. It just means we need to make a few little corrections and get you going right on the right path, okay? So for number 1, when I read twice a number, n plus 6. So remember, a number means that's attached to the n. Okay, so this is all attached, okay? And I'm saying twice n. So that would be 2n. And remember, when we write those variables, we try and write them in lowercase. Just because sometimes it looks goofy if you use the capitals, and eventually, in very advanced math, you might actually use capitals and lowercase. So I've got 2n, and then I've got a plus 6. Adding 6, okay? What you would not want to do is switch the order of the sentence. You would not want to do 6 plus 2n. Even though you're going to get the same result, remember, don't play around with the order of the sentence. Just keep the sentence in its original order if you can. Sometimes the sentences do have to be changed. But just so that you always stay on the same track, make sure you keep the order of the sentence. And this is one of the reasons why this next one is a little confusing if you are not careful. So follow the order. When I say 7 less than 3 times the number, when I'm saying 7 less, this is saying minus 7. Okay? It's not saying 7 minus. All right? And my starting number, less than, remember, you want to put your bigger number up front or what you're subtracting from up front. My starting number is 3 times a number m. So remember, this is all attached, and times signifies multiply. So it's 3m, and now I bring in that minus 7. All right. Whenever you see less than or more than, you know you're going to put it on the end of the expression, okay, at the back. All right, the next one is the total of a number f and 3. So remember, when you see 2 numbers, and remember that f is a symbol for a number. It's a variable for a number. It says it, a number, f. So whenever you see 2 numbers and you see the end, you're going to look for your math verb or your keyword or your phrase that's telling you what operation you're going to substitute in there. And remember, total is addition. So that means I would substitute in addition. So my expression would be f plus 3. All right, number 4. A number x decreased by 13. So a number x, remember that's saying it's a number x. Could be 4, could be 15, could be 1,000, could be a gajillion. I don't even know if that's a real word. Anyway, decreased by, remember we learned that. We focused on that decreased by for number lines, right? Minus 13. X minus 13. I didn't change the order. I didn't go 13 minus x. All right. 12 more than the product of 5 and a number x. Okay, this one's a little bit more detailed, so you have to really pay attention. So 12 more than. 12 more than is saying plus 12. And remember, when we say more than, we say that's at the end of the expression or after another part of the expression. Okay, so now let's look at the other half. The product of 5 and a number x. So the product of 5 and, so that means multiply a number x. So we have 5x plus 12. All right, number 6. The quotient of a number x and the sum of 3 and 7. Okay, well, I've got a couple of ends going on here. So let's take a look at it. First of all, I have this end, and it's saying the quotient of a number and the sum of 3 and 7. So I know that this quotient means that right here, I'm going to be dividing. Okay. Now I have to address the other half, and the other half is saying the sum of 3 and 7. So, and sum means addition. So I have 3 plus 7, and remember that's at the back now. So the 3 and the 7 is at the back, so that means I'm plugging my division in. So really, I need to write it like x divided by 3 plus 7, or the better way is x divided by 3 plus 7. I know that 3 plus 7 is 10, and I understand that you guys know that in your head, so why can't you just write x divided by 10? The problem is right now, it's just asking you to write this as an expression. It's not asking you to solve any part of it. So resist the urge to add the 3 and the 7, okay? Okay, the next one is 17 less than the quotient of 200 and a number y. Okay, here we go with that less than again. 17 less than, that means minus 17, and I'm gonna put it at the end. Now I gotta see what I gotta put at the front. The quotient of 200 and y. So remember, quotient tells me that this is divide. Okay, and these are my two numbers right here. So 200 divided by 7 minus 17. All right, this next one is 15 decreased by the product of a number x and 4. Okay, so 15 decreased by, hopefully you remember, that's minus 15 and it goes at the end. The product of a number x and 4. Product means multiply. So x times 4, and we can switch that. We can say 4x minus 15. All right, so hopefully you're catching on to those little keywords and phrases. Now let's take a look at some actual legit word problems, okay? So again, you're going to follow directions specifically to what the word problem is telling you to do. So first, for number 9, it says your uncle is 2 years older than 3 times your age. For part A, it wants you to write an expression to describe your uncle's age. Use Y to represent your age. Okay? So you need to write an expression for this sentence, and you're going to substitute a Y for your age. Okay, so your uncle is 2 years older. He's 2 years older, so that means plus 2. Okay, that's 2 years older. And then he's older than 3 times your age. But you don't know your age, you're going to use your Y. Well, hopefully you know your age. So that means 3Y. Then what I do is I go 3Y plus 2. Okay? Now, part B says, if you are 12 years old, how old is your uncle? Okay, so now it's telling you, okay, you know what? Now you should solve it. You should work on it, okay? So now you're going to take this and you're going to substitute in 12 and then plus 2. Then you work it from order of operations, okay? So 3 times 12 comes before doing anything without addition. So 3 times 12 is 36. Bring down the 2, and then simply add it. 38. Your uncle is 38 years old. Okay? All right. This next problem, I'd love for you to pause the video. Try to work it out. Remember, first you're writing the expression. And then you're going to do some math with the expression, okay? So go ahead and work out this problem and then press play again and then come back and we'll solve it. Okay, so the problem says you plant a tree that is 10 inches tall. The height increases by 15 inches each year. Write an algebraic expression to represent the height in T years. So essentially, I'm looking at this part right here, and I'm saying this is T. Okay, so it says I planted it, and it was 10 inches tall. So I started at 10 inches, didn't I? So I'm going to put 10. And then it says it grows by 15 inches each year. But I don't know how many years it's been growing because it didn't tell me when I planted it, right? So that means it's 10. It started at 10. And then each year we're adding 15 inches. So that is my expression. All right, then the second part says use the expression to find the height after 9 years. Well, now I simply take this expression, 10 plus 15y, and I substitute the years for 9. Okay, then I got to do a little math, and remember I used order of operations, so I know I have to multiply first. So 9 times 5 is 45, so I'm going to carry a 4. 9 times 1 is 9, plus 4 is 13. Plus the 10, I bring that down, and then I do the simple addition. It's 145 years. And had I said the tree was growing for 10 years, it's the same thing. I just plug in a different number of years. So now it's 150 plus 10, and I get 160. Same thing with the first solution. If they had said that you were 10 years old, you would do 3 times 10 for the variable. So the variable is representing a year that a number of years that somebody has to tell you. What do I plug in there? We'll eventually get to the point where you can figure out the variable in other ways, but for right now, we're just working on it like this, okay? All right, so we have practiced some good problems today, some writing expressions and working with word problems. You do have a word problem activity that you're going to go work on, and I will see you for our next lesson.